Good morning, Mathematics B here. Want to start off by saying uh, happy Tuesday, happy Taco Tuesday. Here in the quarantine and just being adaptable with my students and making sure that they're able to get what they need while they are away from the classroom. So after my lessons, I come in here and I record my lesson again to make sure that they're able to have that information with them. So, start off. Scientific notation. Very simple. Scientific notation is taking extremely large numbers or extremely small numbers and then making them more manageable. Okay. So for a very simple, I'm going to write out this here. This is 73,513. There may be a decimal here and there may be some zeros here, right? But we're not worried about that. Okay. We don't worry about those zeros. That's what we don't do. But in theory, it's good to know that there's a decimal there and those zeros there because that's where this scientific notation comes into play. So I'm looking at this number and I'm going to write this as a scientific notation. So I'm going to count the number of digits after the 7, which is 1, 2, 3, 4, right? So I know that my decimal needs to move 4 places to the left. 1, 2, 3, 4. Okay, remember there's a decimal here and there's some zeros here. So my decimal, take it, I move it to the left. So now I have this number that is 7.3513. Okay, and since I know that I move my decimal 4 spaces to the left, I know that if I multiply this times the power of 10, base 10 to the power of 4, this will be the exact same thing. Remember, decimals. If I move this, I'm doing tens, hundreds, thousands, 10,000s. Well, 10 times 10 is 100. 10 times 100 is 1,000. 1,000 times 10 is 10,000. So my 10,000s place, right? Boom. That's the first one. So if I take a large number like that and I move my decimal 4 spaces to the left, I have one whole number, right? And then it's to the 10 to the power of 4, right? My base 10 to the power of 4. Okay. Next. I'm going to look at a different number. I'm going to look at a number that does not need to move. Nothing needs to move on this number. And this is where you understanding your exponential rules comes into play. So if I had a number like 5.6, right? And I know that I don't need to move my decimal anywhere because I already have a whole number. I have one whole number, right? So 5.6, that's my number. So I'm going to multiply this times 10 because I have to have the base 10 when you're writing scientific notation. But my exponent is not going to be 1. It's going to be 0 because any number to the power of 0 is 1. So this is actually saying 5.6 times 1 equals 5.6. It's going to give you the same thing, right? But it's just knowing that exponent rule, that 10 to the power of 0 is the same thing as 1. All right, it just looks like this. We're not. If you say write it in scientific notation, you're not going to write 5.6 times 1, right? But you have to write this that does equal 1, and that still gives you something times base 10 to the power of something, all right? Next, we have decimals, right? Let's say we had a decimal, like so. 0.1, 2, 3, 4, 5, 6, 7. Let's say we had 3, 2, 4. Okay. Now, this is a very beautiful number. It's a very small number, but if I had to write a bunch of these numbers, this would take up a lot of space, a lot of time. So instead of doing that, this is where we do the opposite. When we have large whole numbers, right, we're moving our decimal to the left, right? And now that we have large small numbers, we're going to move our decimal to the right. So large whole numbers, all right, you're going to move the decimal to the left. Large small numbers or decimals, you're going to move that decimal to the right. So first thing, remember, we want one whole number. So we're going to move this decimal until we get to this first digit, right? So we're going to count our zeros, 1, 2, 3, 4, 5, 6, 7, 8. Oh, sorry, 1, 2, 3, 4, 5, 6, 7. And then our 8th digit is going to be our 3. So imagine I'm going to take this decimal and I'm going to move it all the way over here. Boom, 3. Remember, these mean nothing. There's no value there. So my first digit of value is 3, right? So now I can write this as 3.24, right, times 10. And then if I look, how many spaces did I move my decimal to get to that 3? Well, very simple. We just moved 8 spaces, right? But this is a decimal. This is a decimal. It also can be written as a fraction. So we think about our exponential rules, right? If you have a base number and your exponent is negative, right, then your number becomes a becomes a fraction or a decimal. So this is going to be negative 8. Okay, 10 to the negative 8, right? Boom. And vice versa. If you were given this first, right, you can say, well, they want me to write this out, right, in standard form. Well, very simple. I'm going to look at it, and I'm going to know that I need to move back 8 spaces, right? I need to add 8 spaces back. So, very simple. Take this and I move back 1, 2, 3, 4, 5, 6, 7, right? All right. All right. Let me do another one. Let's say we had a number like 7, 3, 5, 0, 0, 0. So nothing changes. The larger the number, it still does not matter, right? We're moving our decimal to the left. Whenever you have a whole number like this, a large whole number, you're always moving your decimal to the left. If you have a decimal, you're moving your decimal to the. I mean, if you have a decimal, a small number, you're moving your decimal to the right. All right, okay. So remember, this is a whole number. This is my number, but there's always a decimal and there's a bunch of zeros that go on forever that way, right? And so we don't need to worry about those. But what we do need to know is just remember there is a decimal there. And so I'm going to move that decimal, okay, to my left. My left is going that way, okay? So I'm going to take this, and I'm just going to move this all the way over here until I have one digit, right? So this is going to be 7.35. Remember, all these zeros don't count, right? There's no value, so I just keep my value here. But I need to count how many spaces did I move. Well, I know I have 6 zeros here, and this would be my 7th and my 8th digit, right? So no, this is times base 10 to the 8th power, right? Okay.